This podcast is sponsored by the RedHat Developer Program. Download our latest O'Reilly book, Building Reactive Microservices in Java. Learn why Eclipse Vert.x is a good choice to build effective microservice systems. Download it now at infoq.link/RedHat.
Welcome to the InfoQ podcast. My name is Wes Reisz, and I'm your host. I'm also the chair of QCon San Francisco that's coming up this November in the Valley, QCon London held in the UK in March, QCon New York this June, and new this April, a conference called QCon.ai. Like the other QCon conferences, the new QCon AI is focused on peer-to-peer talks for senior developers, architects, and technical engineering managers. The twist with QCon AI is it's an AI ML data engineering conference designed by and for software engineers. It answers questions like when is the right time to apply machine learning practices? Like all QCons, these will feature stories from some of the world's largest consumer-facing apps, so I hope you can join us. On this week's podcast, I'm speaking to the project lead for Vert.x. Vert.x is a polyglot framework that runs on top of the JVM. His name is Julien Viet. Julien is a principal engineer at RedHat and has been the lead since taking over from Tim Fox in January of last year. On today's podcast, we discuss the newly released Vert.x 3.5.0. Then we cover most of the major aspects of Vert.x it offers developers. And finally, we wrap up with what's in store for 4.0. Thank you for listening, and I hope you enjoy this week's installment of the InfoQ podcast. Welcome, Julien, to the InfoQ podcast.
Hi, how are you?
I'm doing really well. So 3.5.0 will be released by the time this podcast comes out. What are the big features for 3.5.0?
So definitely it's RX Java 2. Vert.x has been supporting RX Java 1 since the beginning, since Vert.x 3.0. And RX Java 2 is really what we wanted to have in this feature. And another killer feature we have is the support for Kotlin coroutines. That's something very interesting. It's a contribution from the community, actually.
RX Java 2, that's been rewritten for reactive stream spec, right?
Yes, exactly. RX Java 2 is a different library than RX Java 1. While it's the same, but you have mostly the same API, but it's a different package. I think that, yes, definitely the inspiration is the reactive streams. And one of the motivations they had is that in RX Java 1, the backpressure support is a bit flaky. They didn't think about it at the beginning, and they added backpressure support after they released the observable stuff and all the API. One thing at the heart of reactive streams is backpressure. And in RX Java 2, they provide backpressure support based on reactive streams.
Then you said support for Kotlin coroutines?
Yes, indeed. That's something very new. We had support in Vert.x for a similar thing for a long time. And it's called Vert.x Sync, and it's based on Quasar fibers. And since Vert.x 3.4, we do have Kotlin support in Vert.x, which is contributed by someone from JetBrains, by the way. And from the beginning, I always thought that coroutines would be a killer feature for Vert.x, but I didn't have much time to work on it, and someone from the community, the Zookeeper maintainer, was interested in this feature, and he contributed this for this new release. And my job as project lead was more to review it and improve it and make it more documented and these kind of things. So it's much more usable than the initial pull request. But it's a contribution, so we had a lot of iterations on that. There's people from the Kotlin community as well that reviewed it, so that was very interesting. And most importantly, I will say that since I'm going to speak at Kotlin Conf in November, the topic of my talk is about Kotlin coroutines. So it definitely had to be in 3.5.
Kotlin coroutines is kind of a smoother, less friction way of writing asynchronous code. How does Kotlin coroutines kind of mesh up with what you're doing with Vert.x? Do you just use it, or any special things that you had to do?
So we just use it. I would say that the job that JetBrains and Roman has put in coroutines is really amazing because it's very well done, very well documented. And what is really, really nice, to my opinion, is that the first thing is that it's baked in the Kotlin compiler and in the IDE, which means that it's totally transparent to the user. There are bytecode code modifications, but it's done transparently by the Kotlin compiler, so you don't need to do runtime bytecode manipulations or to have an extra plugin that would mash up your code and transform it. So that's very nice. And the second part I like very much is that it's provided by JetBrains. So basically, the support is great, at least in the compiler, because it means they're going to support it. It will always be up to date. Like today, if you are doing something similar for Java compiler, it will be an open source project. And if the compiler evolves, then the open source project has to evolve and take into account new things, and it may break. And as it's supported by JetBrains, you have the insurance that it will be always top-notch support for it. And the last point is that it's supported in the IDE, so that's just magic. And you can also debug with it, and when you debug, the IntelliJ understands coroutines and works very well. So I think that's a great developer experience for this.
Yeah, definitely very cool. And one of the hotter things right now in software, we actually have Roman Eslerov, who you just mentioned, speaking at QCon SF, which is also in San Francisco and just after Kotlin Conf that you're speaking at. He's going to be talking at QCon about the journey to async and also how coroutines work in Kotlin. I think it's the first talk on Tuesday morning in the Java track. I'm actually running that track. But back to Vert.x and Kotlin coroutines. I'm not sure I exactly understand. What's the actual support that Vert.x offers for Kotlin coroutines?
So in Vert.x, we don't have much specific support. The only thing we provide is the integrations of the coroutines with the Vert.x event loop. That's the most important thing, and we test it. We do also provide specific integration for some reactive types in Vert.x. Like in Vert.x, we have the notion of streams. Read stream, write stream. And so we provide an integration of read stream and write stream with Kotlin coroutines. Sorry, I don't remember the name. You know what they have in Go?
Go routines.
Not the Go routines, the other.
The channels?
The channels, yes. So basically you use them as a stream of data that you can read and write in synchronous manner, and it's very nice.
It was probably, 3-4 years ago, a good buddy of mine named Devin Phillips, who now works for RedHat, introduced me to Vert.x. But let's kind of just start from the beginning and talk a bit about what Vert.x is all about, what its kind of core concepts are, and just kind of build it up. So what's Vert.x all about? What's the goal and kind of the history of Vert.x?
Yeah, sure. So I will try to explain and tell my version of the story and what I think about it. So first of all, yes, Vert.x was created by Tim Fox, I think in 2012. And Tim's background has always been messaging. I met him actually in JBoss in the early days around 2006. And he was already contributing to messaging. He created HornetQ, that is a high-performance messaging system based on Netty. And if you remember correctly, in 2012, it was also the boom of Node.js. And at this moment, Tim went to Pivotal to work on RabbitMQ. So he had to work on Erlang with the Erlang language. So my version of the story is that if you take a shaker and you put all these ingredients, messaging, Erlang, actor model, Netty, Node.js, and you shake it, that's pretty much for me, the recipe of Vert.x. So the first version of Vert.x, I don't know it very well, and I didn't know more Vert.x 2 actually. I think one of the ambition was to provide a Node.js-like programming model for the JVM. And at this moment, in the Netscape, there was no solutions comparable to Vert.x.
So the heart of it is just a lightweight distributed system that uses the event loop that Node uses. Is that accurate?
So Vert.x is based on Netty and reuse Netty's event loop. But it's not only that, of course. Vert.x provides an asynchronous and non-blocking programming model. And here asynchronous is very important because that's the kind of properties you need when you want to implement things like reactive systems or reactive programming. That's the common denominator, I would say. And on top of that, Vert.x 4 provides basic blocks for writing asynchronous client on servers. And it provides also an asynchronous file system. And on top of that, it's a toolkit also for writing distributed applications. So it provides distributed primitives like distributed counters, distributed logs, shared data. And of course, there is the event bus that aims to distribute applications between different nodes of the cluster, but not only, because it can be extended with bridges through other parts of your systems. Like it can be in the browser, or it could be in different process, like we do provide event bus clients for the bridge for systems for language like Go, C#, Python, or Node.js.
Oh, wow. I didn't know you bridged to C#.
Well, it's a client.
So the core concepts within Vert.x are like a vertical, event bus. What's a vertical?
So when you start to use Vert.x, you can just create a Vert.x object and start to write your HTTP server or use the HTTP client or even use the event bus, the asynchronous file system. And you can do that in your main. So you create your main program, you create Vert.x, you start to use all these wonderful tools. Or you can also do it in a test, in unit tests. But at some point, when your application starts to become serious, you want to encapsulate and slice your applications in different functional parts. And that's where Vertical comes into play. Vertical has two roles. The first one is to encapsulate functional logic in different parts. And the second role is that it's also a scalability and deployment unit. So when you make your applications, you create several verticals, and these verticals will contain the different parts of your application, of course, and they will communicate through the event bus. And when you deploy one vertical, by default, it deploys it on one event loop. So if your applications, let's say it's a web HTTP server that access a service, and that service is in a different vertical, they can use the event bus to communicate. And then you can decide if you want to deploy the HTTP server vertical on different nodes and on more event loops. So you have a better scalability. So with that, you can choose how you scale your applications, the different parts of your applications easily. Instead of sizing thread pools, you can say, okay, this part, I want it on 4 event loops. And this part, I want it on 2 event loops because it's less important and it has less traffic, let's say. And at some point, if you want, what you can do is that you can start to distribute your application. So you can keep the HTTP server part in the front and move the services in different VMs on different nodes. And that will be totally transparent to the application because the event bus provides this nice location transparency. So whether it's on the same JVM or distributed, it will work equally the same.
What is the event bus? You say it provides location transparency. What is it? Is this Hazelcast, Zookeeper? How does it communicate between these different instances?
I will try to not be too much technical, but basically, if you're in the same VM, in the same virtual machine, sending a message on the event bus is just moving one message from one event loop to another event loop. Or differently put, it's moving a message from one core to another core of the CPU. And it's done very, very efficiently by all this non-blocking high-performance queue that we can use. But when you start to go distributed, we can see it with this angle that we use a cluster manager, and the cluster manager will basically give to Vert.x distribute the topology of the cluster. So thanks to the cluster manager, Vert.x is able to know where to route the messages on the cluster. And we do provide several implementations of the cluster manager. The historical one is Hazelcast implementation. We also provide an InfiniSpan one, and in the community we have 2 contributors for this. One is with Zookeeper, and the other one is Apache Ignite. Once Vert.x has figured out where to send the message, then it's just peer-to-peer messaging between the nodes. So Vert.x connects to the nodes. It's a Vert.x server. It sends a message. There is a protocol between the nodes, and this protocol is used to send messages to the peers. That's as simple as that.
What is that protocol?
It's an internal protocol. It's a prefix length based protocol that is quite simple. What I wanted to do actually is, I don't have time, but in Wireshark you can write plugins in Lua, and I always wanted to develop a Vert.x event bus protocol plugin for Wireshark, but I haven't found yet the time to do it. But it would be, I think, quite easy to do.
So one of the other interesting things about Vert.x is it really embraces the idea of polyglot programming, right?
Yes, so since the beginning, Vert.x had the ambition to be not only Java. And actually, the first name of Vert.x was Node.x, where X was replacing the JS in Node.js. So it was meaning not Java, not .java, not .ruby, not .whatever. But that was, I think, creating trademark issues, or I don't know, or maybe not a good way to do it. So yes, basically in Vert.x, when you use the Vert.x core API, it's all written in Java. We don't use all these external languages. So if you just use Vert.x with Java, it will be pure Java. And then we provide what we call chimes, which are adaptations of the API for different languages. And when we do that, we try to respect as much as possible the idioms of the language. For example, today we do have Vert.x for Scala. When you use Vert.x for Scala, you will use Scala futures for doing the asynchronous part. When you use Vert.x for JavaScript, it will be a function because that's how you do in JavaScript. The same for Ruby. And last but not least, we also provide support for, of course, Groovy and Kotlin. The support for this language is very much different because they have a very, very good interoperability with Java. So when you use Vert.x for Kotlin or Vert.x for Groovy, you are actually using the Java parts. It's just that for Kotlin, we do provide some syntactic sugar based on Kotlin to provide, for instance, to ease the creations of data objects, all the configurations objects. And of course, also for Kotlin, we provide support for coroutines.
So one of the other things about Vert.x is it's intentionally very unopinionated. It seems like everything I talk about these days is very opinionated. Why did Vert.x decide to be unopinionated?
That's a good question, and I don't have the right answer for that. I think that my opinion is that as soon as you start to be opinionated, you have to force people to do things in a certain way. And today you can take Vert.x and use it with Spring, for instance, or even with Java EE if you like. And it will work very well because Vert.x is very unopinionated with that respect, that it's just a library. It's not a framework, so we don't impose you complex API protocols. It's very, very straightforward, very direct. What you code is what you execute. And also Vert.x is very modular. So we tend to have a lot of different libraries. So when you use Vert.x core, you only pay the price to use Vert.x core. And you will just use NetEase dependency and Jackson mapper. And we try also to keep the number of dependencies very low. Because in Vert.x, we don't do class loading.
Right, I was curious about that. Why no class loading in Vert.x?
We recognize that class loading is a problem that we don't want to solve because that's not our job. And actually, as soon as you start to do class loading, there is always another framework that is already doing class loading. So you basically run into issues. and instead of trying to solve these issues, we prefer to not do class loading and avoid the problem at the source.
That takes us back to the discussion right before we started where we were talking about portal servers, where you had a class loader for the portal server, for the app server, for the web server. It was so many class loaders that I tripped over myself so many times with portal servers.
That was the hell of class loading. And actually, if you think about it and how Java 9 is, it has now been released. And by the way, Vert.x is compatible with Java 9, at least in non-jigsaw mode. But if you think about it, I think that leaving class loading aside was a very, very good decision. That's a decision we take in Vert.x 3 because Vert.x 2 was doing some class loading, and in Vert.x 3 we say, okay, we don't want to do class loading anymore. It's more issues than benefits, by the way. And if people want to do class loading, they can use OSGI or something like this.
So you said Vert.x is compatible with Java 9 if you're not using Jigsaw, if you're in non-Jigsaw mode. So that means using the class path, right?
Yes. So Jigsaw Java 9 has been released very, very recently. And for 3.5, we have tested most of our modules with Java 9. And most of them work very well. They have been tested very carefully. There are a few ones that will not run with Java 9. And basically those are doing class loading stuff. But it's very minor modules. It's more like they are not really used when we checked the statistics.
So what does the developer experience look like? If I want to use Vert.x and I'm talking from a clean slate, from a command line or something, what does it look like for me to get started with Vert.x?
I think the first thing I need to say, and that we always say, is that, that I said before, is that Vert.x is a set of libraries. It's not a framework. So to me, the most straightforward to start is to create a Maven project or a Gradle project and just add dependencies. And then I will create a main, and in that main, I will do my application. And of course, as I'm testing my application, I will just use JUnit. And in the JUnit setup and teardown methods, I will create Vert.x instances, create the HTTP server, HTTP client I need. And as it's very, very fast to start, that has nearly a zero impact on the performance when you're running tests. So it's very simple to use. You don't need external plugins. So people sometimes are used to try to test their application as WAR files. So they need a Maven plugin to start it, or they need also a framework that will start for them the application server. And we avoid that. And basically, our idea is that if you need a plugin to start the application server to test your application, it means that this plugin is just trying to heal the symptom and not to heal the cause. And if you make it embeddable and very, very easy and quick to start, then it's just the same thing but done in the right manner.
Yeah, very nice. That's awesome.
Yes, and now for new users, we provide several ways to bootstrap, because I know that now developers, they want to start and generate applications and, all these generator things. So you just have an already done application and you just have to customize it. So what we provide for this is that we provide two GitHub projects that you can clone, and it provides minimal applications. And we also have a Vert.x examples GitHub repository where you have examples about all Vert.x APIs and all Vert.x modules. So you can take that and copy the parts you want and put it in your application, copy paste. It's very small examples and you can reuse them. And currently we do have one contributor that is working on an idea that we borrowed from Spring. That will be the start.vertx.io website where you can generate an application, choose your build system, and download this application.
That's very cool. I was super impressed when I was getting ready for the podcast. I was looking through kind of the documentation. The documentation is really good on Vert.x.io.
Yes. For us, documentation is perhaps one of the most important things. Documentation and examples. And since for a few months, we have also improved our documentation. I think we do have great documentation for all the different modules, but sometimes people were a bit lost, and often they ask, how do I build my application? Because I don't know how to do it, because Vert.x is unopinionated. And since for a few months, we do have a new guide, a gentle guide to asynchronous programming with Eclipse Vert.x for Java developers. And basically, the idea of this guide is to tell a story. So it starts from the beginning. It assumes you know nothing about Vert.x and nothing about asynchronous application. And step by step, it develops a wiki application, introduce asynchronous concepts, event bus services. And the last two chapters are about Rx, as I explain how to use RxJava to build your application. So that's something I think that was really important to do in the last few months. And we do also have a nice O'Reilly book written by one of the Vert.x core team members that will take you through writing microservice applications with Vert.x. So it's a great read if you're interested in Vert.x.
One other question I have, I know Vert.x is unopinionated, so you could probably do this with anything. But what is the default path for access control, authentication, security with Vert.x? How does Vert.x handle it?
We do provide a Vert.x Auth module that takes care of everything. So basically, this Vert.x Auth module's components, it takes care of doing authentication. And then this component is reused in Vert.x Web, for instance, to provide web application authentications. We also use it in Vert.x Shell to do SSH authentication.
What are you seeing with adoption of Vert.x? What kind of traction are you getting with developers and companies?
Vert.x is a very popular project, that's for sure. One thing that always strikes me when I look at Vert.x, of course, today reactive programming, I think, is a small part of the entire ecosystem. And to my opinion, it will become bigger in the next few years. What strikes me when I look at Vert.x and when I go to conferences and talk to people is how much Vert.x is today used in production by companies. If you go on the Vert.x.io website, we do have this page where we list all the companies using Vert.x. And basically, when we released Vert.x 3.0, we sent an email to the Vert.x list and say, okay, by the way, if you're using Vert.x in production, just send us an email and we will see if we can add your logo on the website. Basically, we had a lot of replies for that, which tells a lot about the current usage of Vert.x in production. So that was very good for us.
I'm actually looking at it. You've got Groupon and Hulu, and you've got VMware AirWatch.
Yes, and there are other names we can't tell, of course, unfortunately. And we do see a lot of new projects starting on Vert.x.
As I said at the very beginning, you just released 3.5.0 or will by the time this podcast goes out. What's next? What's on the roadmap for Vert.x?
That's a very important question. So, yes, I think the most important point here is that Vert.x 3.0 was released almost 2 years ago, a bit more. And we have been developing it and releasing 3.1 to 3.5 now. And my opinion is that now Vert.x 3.x is very mature. We still need to work on it, basically increase the size of the ecosystem and its overall usability. Because when you write reactive applications, the reactive ecosystem is very important. And our mission is really to provide this fully integrated reactive ecosystem. So, of course, when you use Vert.x, you can use Vert.x with non-Vert.x components, and it will work very well in general. But when some components are important, we try to provide an API for it, so it's familiar to the user, and also the user doesn't have to think hard about the threading and everything. Basically, when you use the Vert.x components, all the callbacks will be done on the right event loop, and we will take care of everything. So for Vert.x 3.x, we still have some stuff to do. Maybe integrate more database, more NoSQL access. Currently, we provide access for Mongo and Redis. We don't have out-of-the-box solutions for Cassandra or Couchbase. And the main point is that they provide already very good drivers. So people are using, of course, Vert.x with these solutions, but maybe we could implement specific modules to integrate it better with Vert.x. That's something we need to see. We start to think a bit about what will be Vert.x 4. So one thing that is important to say is that Vert.x is an Eclipse project. And it has, I think, to my eyes, and that's very important, a good community of contributors. Basically, the core team, what we call the core team, has RedHat employees, and we are only 4. And in the community, we have contributors. For instance, Vert.x for Scala was fully developed by Joshen. And without that, we could not develop it because we have no Scala skills. And as I said before, we also have contributions on cluster managers, on Zookeeper. Contributions on the Vert.x console client has been fully developed recently by Ruslan. And my point is that when we will start to think about Vert.x 4 more formally, we will involve the community because I think that here Eclipse plays an important role and tries to, even if RedHat is the main sponsor of the project and the main driver, the community around Vert.x is broader than just RedHat, and that's quite important to me. And last year, we did a face-to-face meeting for Vert.x 1 year ago. And for that face-to-face meeting, it was a good opportunity for the developers to meet, so the core team, of course. But this face-to-face meeting was open to anyone that wanted to come. And we had people from the community coming to this meeting. So it was very good. And I think that for Vert.x 4, we will do the same. I just wanted to add that for us, Vert.x 4 will be the opportunity to have a new iteration and see what has worked well and what didn't work. For instance, that's something we did between Vert.x 2 and Vert.x 3. As I said, between Vert.x 2 and Vert.x 3, we simplified some things. We removed the custom class loading, and it was a very good thing. So Vert.x 4 will be the opportunity to think about the current status, what works, what doesn't work, and try to make an iteration to improve it.
Well, very nice. It sounds awesome. Looking forward to seeing it. If anybody wants to see more, just send them out to Vert.x.io. Is there any place in particular they should go?
I think the Google group is the best place to ask questions and get answers. Not only from me, from the core team, or for the entire community. We do have good contributions there as well.
Well, Julien, thank you for taking the time to chat with us on the InfoKey podcast.
Thank you.